All right, welcome. Today, we are going deep on one of the unsung heroes of the industrial world, the separator. We're going to follow this thing through its entire journey, from the planning stage out to the well site and all the way through to the end of its mission. Let's get right into it.
So first things first, what is a separator? Honestly, the best way to think about it is like a colander from your kitchen, but on a whole other level. We're talking a high-pressure, high-stakes, industrial-strength colander. Its one job is to take that messy mix of stuff coming out of the ground, oil, gas, and water, and split it all up nice and clean. It sounds simple, but the engineering to make it happen safely is anything but.
So here's our roadmap. We're going to follow this thing's entire life cycle. We'll start with mission prep, then the rig up when it gets to the site. Then it's go time when it's actually doing its thing. After that, we'll look at the all-important health check. And finally, mission complete, the rig down process.
Okay, so our story begins way before this piece of equipment ever sees a well site. This is the mission prep phase. And let me tell you, the work done here is absolutely non-negotiable. Getting this part right is the foundation for everything that follows, for both safety and, actually getting the job done.
The attention to detail here is just incredible. I mean, before anything moves, they're running software simulations to predict how the pipes are going to wear down from erosion. They make sure to pack 2 spare pressure relief valves because you just can't afford for one of those to fail. If they're heading into a harsh environment with nasty stuff like H2S or CO2, they use these special seals. And get this, they actually take the most sensitive instruments off the unit to protect them during the bumpy ride to the site.
And here is a perfect example of a rule you just don't break. For jobs with really high pressure and high temperatures, you are not allowed to use standard thermal wells. Those are the probes that stick in to measure temperature. Why? Well, because the sheer force of the flow can literally rip them apart inside the pipe, causing what they call a washout. It's a total catastrophe. So they have to use non-intrusive sensors instead.
All right, all that prep is done, and now we've landed on site. It's time for the rig up. This is where the crew puts everything together, piece by piece. All that careful planning is about to pay off. And believe me, precision is the name of the game.
The rig up is like a carefully choreographed dance. It all starts with a simple visual check. You're looking for any dings, dents, or cracks from the journey. Next up, they check the sight glosses, tightening the bolts to a very specific torque. Then, they go through all the controllers, making sure the pneumatic regulators are set just right. In this case, 35 psi. And finally, those critical pressure relief valves get installed, always vertically and with the right support so they can handle the incredible forces if they ever have to blow.
And now it is go time. The valves are opened, the flow begins, and the separator starts doing what it was built for. This is where the operators take over, fine-tuning the system to get that perfect separation of oil, gas, and water.
Now, this isn't a set it and forget it kind of deal. You have to tune the separator based on what the well is giving you, specifically its gas-to-oil ratio, or GOR. If you've got a really gassy well, you keep the liquid level inside the separator low. That stops liquid from getting sucked into the gas pipeline. But if it's a really oily well with a low GOR, you do the complete opposite. You run a high liquid level to give the oil and water more time to separate out properly. It's a constant balancing act.
Okay, but here's where things can get really hairy. What happens if the well starts spitting out solids? We're talking sand, grit, little bits of rock, all flowing at high speed. It basically turns the inside of the pipes into a sandblaster, and that creates a massive risk for erosion.
So just how big of a risk are we talking about? When solids are in the flow, crews are mandated to check the pipe's wall thickness with an ultrasonic scanner every 2 hours. Think about that. Not once a day, not once per shift, every 2 hours. That is the kind of extreme vigilance it takes to prevent a pipe from wearing thin and failing catastrophically. Here's another one of those golden rules you just don't mess with. You never ever bypass the separator before you've shut in the well. If you do, you'll cause a sudden massive pressure drop. That shock can not only damage equipment, but it can also completely ruin the super expensive and totally irreplaceable data that's being recorded by instruments deep down in the well.
So, the job is done, but the separator's life is far from over. Now it enters a really important phase, the health check. This is all about scheduled maintenance and certification, a super strict process to make sure it's safe and ready for the next mission.
This maintenance program is all tiered. After every single job, it gets what's called a CBM-1, basically a flush and an inspection. Once a year, it gets a more detailed CBM2, which includes those ultrasonic wall thickness tests. And then, every 5 years, it's time for the big one, a CBM3. This is a major recertification where they fill it with water and pressure test it to 1.5 times its normal working pressure.
And speaking of pressure testing, the rules here are ironclad, and for good reason. You always test with a non-compressible fluid like water. Why? Because if a tiny leak develops, the pressure just drops instantly. It's safe. You are strongly discouraged from using a gas, because compressed gas stores an enormous amount of energy. If something fails during a gas test, it doesn't just leak, it can explode.
And that brings us to the final chapter of our separator's mission, the rig down. This is more than just packing things up. It's a precise procedure to protect the equipment, protect the environment, and get this unit perfectly ready for its next call to duty.
The rig down checklist is just as important as the rig up. They drain every last drop from the vessel, then flush the whole system with a corrosion inhibitor to keep rust away. All the connection points get sealed up tight to prevent any spills. And here's a cool little detail. They actually leave the ball and gate valves in the open position. It sounds wrong, but doing that actually takes the pressure off the internal seals and protects them from getting damaged while it's in storage.
So there you have it. From that first computer simulation all the way to that final flush, you can see that every single moment in the separator's life is absolutely dictated by 3 things: precision, relentless planning, and an obsession with safety.
And that kind of leaves us with one big question to think about. When you have this many safety checks, this much engineering, this much planning, what's really the biggest risk out there? Is it the machine itself failing, or is it the potential for human error? Something to chew on. Thanks for tuning in.